All right, looking at the calendar before we get to the lesson today, we have a homework. We'll make homework due on Thursday, Friday of this week, and it'll be pretty much everything up to what we do today. So up through page 68. Won't include 202. Won't include tomorrow's assignment because we won't have had time to kind of discuss and go over it. So I want to have gone over it before I take it up from you. So up through what we do today will be due on Thursday or Friday. Obviously, hurricane or tropical storm Laura, maybe it's a hurricane yet, I don't know. That may mess with our plans. If it does, just pay attention to email, and likely we'll just push back however many days we close. If we close, like I don't have any inside information, but since the track is kind of altered toward us a little bit, if we close, pay attention to email. I'll send out something and we'll figure it out later. Hopefully we don't have to, but I fear we will. So no fun. That's what 2020 needed, right? Was a hurricane to come right at us. Any questions on the syllabus, calendar, test? Anything? Not yet? Okay. Squeeze theorem. Today so the notes are short. I don't know how else to say it. It probably could have been sandwiched with a different unit, or a different day. But it's a good day, an easy day. By the way, it's also sometimes called the sandwich theorem. This is one of those that makes complete sense. After you see it and understand what it's talking about, I think it's just gonna. I think it's one of the easier ones to understand. Again, there's some technical jargon to fight through, but once you understand what all the symbols and words mean, the concept is simple. If h of x is less than f of x is less than g of x, in an interval containing C. You may already see where we get the name sandwich theorem from. F is sandwiched in between H and G. F is going to be squeezed in between H and G. So right now it's just a sandwich. The next line is going to make it a squeeze theorem. So there's one part of the if. The second part of the if, the limit as x approaches C of h of x equals L and the limit as x approaches C of g of x equals L then we are about to get squeezed in. Then you might guess the conclusion. The limit as x approaches C of f of x equals. So f is always sandwiched between h and g. The lower limit, or for h, the bottom one is L, the top one is L. So if I squeeze f in between these two limits, what does the limit of f have to be? No one wants to say it? Worried you're not right? All right, let's draw a picture then. So G's bigger than H. So there's G. There's H. F has to be sandwiched in between there. x equals c. So what does the limit of f of x have to be? L. It has to be L, because the limit above it is L, the limit below it is L, so it's got to be squeezed in there to be L. So it's like, well, yeah, why is that we're spending a whole day on that? And the questions to invoke the use of the squeeze theorem have to be kind of weird, because there's really very few functions that it really works for. So let me just show you what the questions look like. Find the limit as x approaches c of f of x if c equals 2, and so we're going to get this weird function, because it has to be a couple of kind of strange functions for this whole thing to work. So 3 minus x minus 2 squared is less than or equal to f of x is less than or equal to 3 plus x minus 2 squared. Okay, well, I don't know the limit as x approaches 2 for f of x, because I don't know what f of x is. So I can't substitute, I can't do any tricks, there's no picture to look at. So I really have no idea what the limit for f of x is, except that f of x is sandwiched or squeezed in between these other two. So if by chance these other two have the same limit, then I know f of x will have the same limit as they do. So in order for this to work, let's see if these two things have the same limit. So if c equals 2, 3 minus 2 minus 2 squared, well, that would be 3. 3 plus 2 minus 2 squared, that would also be 3. Well, if I'm going to squeeze f of x in between 3 and 3, then I'm pretty sure the only place for f of x to go is 3. So working with it is maybe a little bit complicated, but the concept is just super simple. It gets squeezed in there. There's no place else for it to go. All right, example 2 is going to be with calculator. By the way, this mirrors the two types of problems in the assignment today. It's not long, but there's two types. Graph y equals absolute value of x, y equals negative absolute value of x. Oops. Start that one over. Negative absolute value of x. And y equals absolute value of x times cosine of x. And then use the graphs and the squeeze theorem to find, and since we're looking at pictures, it's really going to be more of a guess, approximate. I mean, it's going to be obvious when we look at the picture, but we're not doing anything analytically to say for sure what the limit is. Use the graph to find the limit as x approaches 0 of absolute value of x cosine of x. That's a whole lot of words, but if it says use the squeeze theorem, then I'm pretty sure this guy needs to be squeezed in between the other two. So that's why it says graph them to see. And if he's squeezed in between the other two, then we can use the other two to figure out this one's limit. So again, the trouble with using my phone is that if a friend texts, you're going to see the text. So y equals, I don't need the tangent thing. Absolute value is under math, num, so absolute value of x, negative absolute value of x. I'm going to change my window back to normal. So I haven't graphed the cosine one yet, but there's absolute value of x and negative absolute value of x. That we hopefully could have done without a calculator. Next, let's do the weird one. Oops, not mode, but math. Whoops. Get there in a minute. There we go. So math, absolute value of x times cosine of x. And let's see what happens here. Okay, that's kind of cool looking. So, sure enough, the weird one, the cosine one, is squeezed in between, is sandwiched in between the other two. So if those other two have the same limit, then the cosine one's got to have the same limit. And I suppose I could zoom in if I wanted to make sure. But I'm pretty sure I know what's happening here. Both of those clearly go to 0. And even though I can't see exactly what's happening with the cosine, the book is telling me to use the squeeze theorem, so I think I can assume that it's always squeezed in between there. And so it's got to be 0. It just gets squeezed into 0. All right, the assignment, page 68, 89 to 93, all. And we'll go over those tomorrow as much as we need to, but probably won't be very much. So, got a few minutes left. You could start work on those. I'll take a picture and post it to the Schoology so you can find access there as well.